When we plan a network build for a new site, the physical topologies are pretty much standard. However, creating network address plan is still often manual. In this video, I'll show how we can standardize the network topologies in YAML file and generate network address plan completely through automation. Here is a small office topology. We have a single WAN router, then we have L3 access switch, a console server for out-of-band management, and optionally, if the small office has a lab, we can enable the lab gateway. And this is the medium office site where we have redundancy in the designs. We have two WAN routers and two core layer switches, like you can consider it core or distribution switches. Both are interconnected. We can have the HSRP protocol running, and on a VLAN basis, we can have either of the switch actually forward the traffic. We have access switches. Based on the number of flows, we can have 1 to n number of access switches connecting to both this core. And we'll have a console server for out-of-band management, which will be connected to the core switch. And then we have an optional lab and voice gateways. So this is like a general standard topology which we come across for small sites and medium offices. Now I would like put the entire physical topology in the YAML file. Let's look at the YAML file. Now we have the physical topology defined in the YAML file for both small sites and medium sites. We can see we have mandatory WAN gateway, flow switch, console server, and wireless access points, and an optional lab gateway. And here the redundancy, as we saw in the topology, WAN was single core, there was no core switch, and then we have the single console server. These are the models we are using. For the WAN router, it's Cisco 8300, and for the flow switch, it's Cisco 9300. We are defining the power supply unit count and the cable. Everything which is important for the physical topology is defined here. Similarly, for the medium sites, we have the similar devices, and redundancy would be dual for WAN and dual for core. And talking about the connectivity, we define the roles: WAN gateway, access switch, then core switch, then we have the console server. So we need to define like what port in WAN gateway connects to what port in access switch. Similarly, what port to core switch. That is fully defined here, along with the SFPs, what kind of fiber cables are connected. We are defining with as much granularity as possible because this will also help us generate the bill of materials as well, and also the patch plan, which will be showing, which I will showing in the next video. So everything is defined here. Then we define the VLANs. In our case, we want to have 100 as the data VLAN, 150 as the voice, 200 as the guest, and 300 for infrastructure services for as any IP address to the crosslinks, and for the wireless access points. Yeah. So this is like the entire physical topology is now defined in the YAML. And as a demo, let's take BGL as a small office site. Here I have this infra subnet block and user subnet block. And I'll say I want lab service to my small office. And my office is in the first floor with 11 AP count and one stack switch with 3 members. Let me go ahead and generate. I'll go to the code. Python 3. Generate address plan, import, BGL import. So it generated the BGL address plan. Let me open this. So if we look at this, we have the infra and user block, which was given, which we had defined in the YAML. Then we have WAN gateway. So WAN to console server is, sorry, WAN to switch. We have the /30 subnet card out of /24, and we have assigned the IP .1 and .2. Then WAN to console server, a next subnet block /30 is carved from that infra, and the IPs are added. Similarly, for the loopbacks, we have 1.65, 1.66. This is a subnet which it carved from the infra service, and with that it is assigning the IP to all our devices, the loopback devices. Then we have data services VLAN 150 for voice. And if we look at this, this would be the default gateway IPs, and that is also created. And for all the access points, we had 11 access points defined, and all of them have were the IP address. So here we don't want the IPv6 for the access points. That was my design. But if you want, we can improve that code to add the IPv6 as well. Here, for all the associated IPv4 address, we have the IPv6 as well. This is for a very small site. We can see the entire address plan is generated. Now let's take an example of NYC. Here we have the same infra and user block defined, but I want lab and voice as well. And also, like, now I have this, because this is a medium site, I have two floors, and one is in the 11th floor and another part is in the 21st floor. 11th floor has 15 APs and 25 APs in the 21st floor. Similarly, two stack switches are there. Now let me go ahead and generate for the medium office, which is NYC. Now I can see medium office address plan is generated. Let me reveal that in the Finder. Yes. Now you can see again in our case of medium office, we had dual WAN and then dual core switch. And for all these are L3 links. So we have the subnet card out of the infra block. Now we have 4 IPs, then next four IPs. So these IPs are card with /30 subnet, and this is assigned to WAN gateway 1 to core switch 1, WAN gateway 1 to core switch 2, WAN gateway 2 to core switch 1. Similarly, all the assignment has happened. Then we go to core switch to core switch connectivity. Then we have core switch to lab gateway connectivity. Similarly, core switch to voice, and all the loopback IPs for the devices what we had defined. And similarly, the default gateway IPs for the each VLAN, what would be that, and all the APs, like we had around 15 APs in 11th floor, all of them have got the IP, and similarly around 25 APs in the 21st floor, all of them have got the IP. In this way, we have generated the address plan for an entire site by defining uh, things in the YAML and using Python to generate. Now let me walk through the code. Here is the generate. Let's go to the main function here. So we'll be loading all the YAML files which are defined, and then we are going to like we have defined the class address plan, and like let me go to this. Here we have everything defined, all the functions like topology, device names, connections, what are enabled, then IPv4 to IPv6 host. All the functions what is required to generate each block is granularly defined, and then we will be calling for crosslinks. Each functions will be called generate crosslinks, generate loopbacks, then user VLANs, then VLAN 300 for infra services. So everything is called in order. If this was like built like generated with the help of AI, and if you want to change any particular VLAN or anything, we can define it in the VLANs YAML file, where we can change these YAML structure, and that can be like based on the organization, the same can be generated with a different VLANs. This entire code is added in my GitHub. You can go to my account Prasravi, and you can see the network address plan automation repo. Everything what I explained in this video is pretty detailed in the README of this. You can refer this. And for your organization specific, you can update the VLANs, the infra subnets and everything, and try generating address plan through automation for next and for feeds. So with this unique approach, We have the physical topology defined in the YAML, and for every new site, we have a repeatable way of generating the address plan for small and medium sites. I hope this video was helpful and you will be able to use this in your organization. Thanks for watching and see you in the next where I will be discussing the patch plan automation. Thank you.